A sonic boom is a sound associated with shock waves created when an object travels through the air faster than the speed of sound. Sonic booms generate enormous amounts of sound energy, sounding similar to an explosion or thunderclap to the human ear. Common examples of breaking the sound barrier are jets and whips. An object, such as an airplane, traveling faster than the speed of sound is said to have a supersonic speed. Such a speed is often given as a Mach number, which is defined as the ratio of the speed of the object to the speed of sound in the surrounding medium. When a source of sound moves at subsonic speeds, the pitch of the sound is altered as we have seen. But if a source of sound moves faster than the speed of sound, a more dramatic effect known as a shock wave occurs. A sonic boom is made of two or more booms and only lasts a fraction of a second, but the energy it contains is sometimes sufficient to break windows and cause other damage. Assume that the speed of sound is 343 meters per second. An aircraft traverses at 410 meters per second. A. What is the Mach number of the aircraft? B. What is the angle between the path of the aircraft and the shock wave? To find the Mach number, the formula is the speed of the aircraft divided by the speed of sound. So in this question, that's 410 divided by 343, which is 1.20. So 1.20 is the Mach number of the aircraft. To find B, we know that sine theta is V over Vs, which is the inverse of the formula to find the Mach number. So using this formula, we put 343 divided by 410, which is equals to theta equals to 56.8 degrees. In pulse echo testing, a transducer sends out a pulse of energy and the same or second transducer listens for reflected energy or an echo. Reflections occur due to the presence of discontinuities and their surfaces of the test article. The amount of reflected sound energy is displayed versus time, which provides the inspector information about the size and the location of features that reflect the sound. The reflection of sound is used in many applications to determine distance. The sonar or pulse echo technique is used to locate underwater objects. A transmitter sends out a sound pulse through the water, and a detector receives its reflection. The diagnostic use of ultrasonic medicine in the form of images, sometimes called sonograms, is an important and interesting application of physical principles. A pulse echo technique is used much like sonar, except that the frequencies are used in the range of 1 to 10 MHz. A high-frequency sound pulse is directed into the body, and its reflections from boundaries or interfaces between organs and other structures and lesions in the body are then detected. Tumors and other abnormal growths or pockets of fluids can be distinguished. The detection of reflected pulses by the same transducer can then be displayed on the same monitor. The time elapsed from when the pulse is emitted to when each reflection or echo is received is proportional to the distance to the reflecting surface. The strength of a reflected pulse depends mainly on the difference in density of the two materials on either side of the interface and can be displayed as a pulse or as a dot.